Today we are finding equivalent algebraic expressions. We're determining if two or more expressions are equivalent. Okay, so in order to do that, we are going to combine and expand in different ways to compare expressions. So in this first one here, we have 2x plus 4, sorry, 2 parentheses x plus 4 plus x plus 8. So if we simplify this completely, uh, and we simplify the other one completely, when it's fully simplified, they should be the same if they are in fact equivalent. So let's see what that looks like. So we're going to utilize our distributive property here, 2 times x and 2 times 4, and we are going to get 2x plus 8 plus x plus 8. And then we are going to combine our like terms. So I have 8's and I have x's. 2x plus x is 3x. 8 plus 8 is 16. Okay, I'm going to do the same thing to the second one. 3 times x, 3x. 3 times 4 is 12 plus 4. I have 3x. Combine my like terms, 12 and 4 make 16. These are equivalent, so yes, they are equivalent expressions. Let's take a look at this one. If we distribute this, I get 2.5 plus 2.5 times x would be 2.5x. Okay, and over here I have half x plus 2.5x, which would give me 3x. These are not equivalent. Okay, so they are not equivalent. Or they're not the same, so they're not equivalent. Okay, and you can try the next two on your own there, but we are just simplifying, combining like terms. And this one says use substitution to determine whether or not expressions are equivalent. That means I can pick a number and substitute it in for the variable to determine if these are the same. So if I say x is 2, I'm going to substitute that in 5 times 2 plus 2 plus 3 times 2. And that should equal the same thing as 8 times 2 because I'm using 2 for x in every single spot. Okay, so 5 times 2 is 10 plus 2 plus 6. 10 plus 2 is 12 plus 6 is 18. 8 times 2 is 16. Those are not equivalent. All right, now just to show you, I am also going to pick another number to double check. Okay, so let's say, and you can pick any number for x. Okay, I'm going to also pick 1. What if I pick 1 for x? 5 times 1 is 5 plus 1, oops, plus 3. 3 times 1 is 3. So 5 plus 1 is 6 plus 3 is 9. And then 8 times 1 is 8. Well, 8 does not equal 9, so it is not equivalent. So these are not equivalent. All right? And you can try that one there with whole numbers. And let's do the same thing here for this one. Now, my denominator here is 5, so I'm going to pick x equals 5 because that's going to be a lot easier for me to work with. If x, we have 5 minus, and then 1/5 times 5 gives me -1, and -2/5 times 5 gives me -2. So 5 minus 1 is 4, minus 2 is 2. This one, I'm going to have 2 times 1/5 times 5. 1/5 times 5 is 1, so 2 times 1 is 2. So these are equivalent, so they're equivalent. And again, you can double check that with another number, x equals 10. I picked another number that is divisible by 5 again to make it a little bit easier. So if I would have 10 minus, and then 1/5 times 10 is going to give you -2. And then -2/5 times 10 is going to give you -4. 10 minus 2 is 8, minus 4 is 4. And then 1/5 times 10 is going to give you 2, so 2 times 2 is 4. So again, those are equivalent, so it is equivalent. And you can try number 8 there on your own as well. Here, they just have you simplifying, which we've practiced at the beginning. Find my like terms. Okay, 8x and 2x are like terms. 4 and 3 are both constants, so they are like terms. 8 plus 2 is 10x. 8x plus 2x is 10x. 4 plus 3 is 7. And this is our simplified problem there. Okay, you can try that one on your own. That is just a review. Okay, let's take a look at ones that have exponents. Okay, so 2x squared and 3x are not like terms. Okay, they have to have the same exponent. So 5x squared and 2x squared, those are like terms. 3x and 4 do not have a like term with them, so they just stay the same. 2x squared plus 5x squared is going to be 7x squared plus 3x plus 4. Typically, when these are written, the highest exponent goes first, okay? And that's how it is listed. That's why I put the 7x squared first, then 3x, and then the constant last, okay? And you can try that one on your own. Let's take a look at one with some fractions involved, okay? So we have half x squared plus 3x plus half x squared plus 2. So again, my half x squared and half x squared are my like terms. I add them. 1/2 plus 1/2 is 1 whole. So I get x squared plus 3x plus 2. Stay the same. And that is your simplified version there. Okay, you could try 16 on your own. Okay, and 17 gets a little more complicated with some fractions and some distributive property. So parentheses come first in your order of operations. So we're going to go ahead and do that. So 3/5 stays the same. And then 3/4 times 12x is going to be 9x. And 3/4 times 4 is going to be 3. And then they're all positive, so they stay positive. Plus 2 and 2/5. Okay, then I combine like terms. I'm going to combine my 3/5 and my 2 and 2/5 first because 3/5 plus 2/5 is 1. So this equals 3. So I have 9x plus 3 plus 3. And because they're all addition, I could do it out of order and it didn't matter. Then 3 plus 3 is 6. 9x plus 6. Okay, and you can try 18 on your own.